Just this one time.
We won the election.
What?
We won the election.
Who did?
PKR.
Oh, the Malaysian Party. Is that the current government?
Yes.
PH. Is that a good thing or a bad thing?
It's a good thing.
Is it?
Yeah, because we lost for like since independence.
What? Now, be quiet. So, results. That's a little bit different to the analysis. The difference is, in the results section, you're not to have any calculations done yet. It's literally just the data. Whereas in the analysis, you have things like the calculating the A and all this stuff. But also, you need to have the uncertainties as well. But how many things did you collect? Well, N firstly is the number, the trial, just which, first run, second run, third run. Then you have U, okay? And then beside U, no, you should have uncertainty U, which is going to be the same for all of them, because it's 0.01 is the smallest reading, isn't it? So it's half that. And that's going to be the same all the way down. And then it's the same for V and the uncertainty in the V. And what else did you collect? The S. And the uncertainty in the S. About quarter maybe of a millimetre, or maybe even less. Maybe, it depends how accurate you feel you could measure it. A quarter or a tenth, I'm not sure. Yeah, but this is an example of where, there's other things that could have gone wrong, like it's not parallel, or, I don't think, unlike the light gates, there's more opportunity for an error. So I don't think it's half the smallest in this case. Okay, what else? The mass, the hanging mass.
The mass should be equal, right?
If you like. And then lastly, the uncertainty in the hanging mass. Now that's interesting. What's the uncertainty in the hanging mass?
0.5.
What?
kg.
Half a kilogram uncertainty?
Because the minimum is 1 kilogram.
No, it's not.
Oh, it's 100 g. So it's 50 grams.
If the weights are in grams, 50 grams, 5 grams, half a gram, I would have hoped.
No, the minimum.
But it does seem like a lot.
The smallest is 100 grams.
Yeah, but all the weights are used in grams, so that my point is they're accurate to the gram. It's not like if the weights were saying, if the weight said it was 100.5 grams, then they were made to be accurate to a tenth of a gram. You get, but I think half a gram is fine because not only is maybe the wrong weight, but also maybe parts of it chipped off, things like this.
A half gram.
Half gram, yeah. Half a gram. So, you see the result has only what you collected and its uncertainty. That's all it has. So it's a little bit different to your table in the analysis. The US, I'd say, I would say 2 millimeters. 2 millimeters. I think this is reasonable. Yeah? So, what do you need for the results? Have a look. Do I have my table with the uncertainties? There you go. Are my units correct? Don't forget your units. Are my measurements appropriate? Well, they are, because I think everybody started on 50 grams.
50 grams.
Of what?
Was the first weight, was it?
100.
Yeah,
100, 150?
100 grams, then 200, 100, 100.
Really? I thought you went up in 50s.
No,
Oh, okay. Anyway, that's fine too. Were there repeated results?
Yeah.
Yeah, you did everything twice. Was the data presented clearly with uncertainty? Well, if you put in a table like this, it was. Was the range of data appropriate? Did you go from a good small number to a good big number? So you went from 100 to... Okay, good, yeah, okay. Yeah, so this one's quite easy. This one's quite easy. Procedure, and results. Which one? Just the row number. Row 1, row 2, row 3.
Oh, you have to write it.
Yeah, well, it's good. It's good to know the order that you did the experiment in. There's no reason for the reader to think that the order here is the same order that you collected the results in. No, but the reader doesn't know from the table that the table's presented so that the first experiment you did was the first row. That's why I put the M here. Now, do you want me to check what you have?
So 1 and 2 is the same.
1 and 2.
I mean, 1 and 2 because we repeat every.
Yeah.